Taking a look at the northern Atlantic sea surface temperature anomalies, and we do see that the sea surface temperatures are much warmer than average. They're close to record breaking, if not they are record breaking when it comes to how warm the sea surface temperatures are at this point. And that's very concerning because we'll likely see a hyperactive hurricane season in the northern Atlantic, despite the fact that we're going to be in an El Nino. When there's warmer than average sea surface temperatures, we see overall a lot more lift in over the northern Atlantic, which allows more convection to occur, which fuels more tropical cyclone development, and that's expected to happen this hurricane season, with sea surface temperatures all throughout the northern Atlantic much warmer than average, including the main development region, the main region where most tropical cyclones form within any given hurricane season. And that's certainly going to fuel the convective activity for much more tropical cyclones to form this hurricane season, which is the reason why I believe that we're more likely than not going to experience a hyperactive hurricane season. Another thing we need to take a look at is the climatology models, because they give a good indication of the more long-term future when it comes to convective activity, how much moisture or how dry a specific area will be, and also how much wind shear there will be in the more long-term future. And we do see that based on the CFS computer model, we're seeing much more moisture than average, that's expected right over the main development region as well as portions of the Caribbean. And this is very concerning because, of course, the more convection we see over the main development region, the more likely we're going to see more tropical cyclones develop and an enhanced risk of hurricanes of developing right over the main development region this hurricane season. And this is a 3-month average between August, September, and October, the 3 most active months of the hurricane season. And since we're seeing much more moisture than average over the main development region as well as portions of the Caribbean, I suspect that we're going to see much more tropical cyclones than average right over this region, which is definitely a major concern. We need to take it with a grain of salt still, because it certainly climatology models certainly aren't correct all the time, as they're bound to, of course, make mistakes. But based on all the indications we've been seeing by a multitude of computer models, I expect that there's going to be an enhanced risk of convective activity over the main development region, and you should more likely than not expect more tropical cyclones to form over this area, despite the fact that we're going to experience an El Nino. Another thing that's very concerning is taking a look at the wind shear map over the northern Atlantic, the forecast for the next 3 months. And let me show you guys the 3-month average right now. We do see that there's expected to be less wind shear than average right over the Caribbean as well as portions of the main development region, while areas such as the western Atlantic, the northwestern portion of the northern Atlantic, should experience slightly more wind shear than usual. However, most tropical cyclones develop in this area right between the main development region and the Caribbean, and since we're seeing less wind shear than normal over this area, I expect that will continue to fuel tropical cyclone development this hurricane season. So that's the reason why I'm expecting this hurricane season to fall closer to more hyperactive hurricane season than, let's say, an average hurricane season like we were initially expecting a couple months back when taking a look at the fact that there's going to be an El Nino. Now it seems like the record-breaking sea surface temperatures, along with the fact that the climatology models are expecting a little bit more moisture than usual and less wind shear than usual despite an El Nino, I expect that we're going to be in for a very active hurricane season, unfortunately. So the potential saving grace that could prevent us from maybe experiencing a hyperactive hurricane season is the fact that we're under a weak to moderate El Nino, and that's expected to continue on for the rest of the summer, where we see that during an El Nino, we see a lot more rising air over the Pacific thanks to warmer than average sea surface temperatures. And since so much air has risen over this area, that air needs to sink somewhere. And of course, air molecules don't like to be very compact and very close together, so they spread out and they want to sink to where there's more space, and that happens to be over the northern Atlantic, where we see a lot more sinking and stable stable air thanks to how much rising air that's going on over this area. There needs to be an equal amount of sinking air, and that typically happens where the air pressure aloft is lower and we see much more sinking over the Caribbean. And so this could potentially limit this hurricane season from, let's say, becoming record breaking. However, it's good to point out that the El Nino effect doesn't have as much of an effect further eastward, where the main development region would be as affected as much as the El Nino typically has more of an impact over the Gulf of Mexico and the Caribbean. So even if we do see a stronger than usual wind shear as well as more stability over the Gulf of Mexico and the Caribbean, the main development region still shouldn't experience much of the effects you'd see from an El Nino. And combined with the fact that sea surface temperatures are record breaking when it comes to how warm they are, I expect that despite the amount of stability and the amount of wind shear that an El Nino brings, that we should still see more tropical cyclones than usual this hurricane season, as we've never seen an El Nino year where the sea surface temperatures were this much warmer than average. Another thing that's good to take a look at when forecasting the amount of tropical cyclones you should expect for the Northern Atlantic this hurricane season is taking a look at analog years. And what analog years are is years that are very similar to the current time period we're experiencing right now. And the two analog years, or the years that are the most similar to this hurricane season that I saw based on the Enzo intensities over the years, were the 1957 hurricane season as well as the 1976 hurricane season, where both of those hurricane seasons came off of 3 consecutive La Nina hurricane seasons and entered an El Nino. So we're going to need to take a look at those 2 years to determine to maybe determine the exact trajectory of where tropical cyclones will move, as well as the amount of tropical cyclones you should expect for an El Nino year that's coming off of 3 consecutive La Nina years, which is what we're experiencing right now, because the 2022, 2021, and 2020 hurricane season we're all experiencing a La Nina year. So I believe that those years are good to take a look at when to really determine how to potentially forecast how this year will turn out based on historical data. Of course, every year is different, so there's still a high possibility it could be completely different from what you'd expect from what those similar years were experiencing, but it's at least a good reference point and could help us in determining how many tropical storms will form this hurricane season. So this is how the 1957 hurricane season looks like, and we do see that it was considered a below average hurricane season, with less tropical cyclones forming than usual. Only 10 tropical storms formed this hurricane season. We did see one major hurricane, in fact, right over the main development region, but really not much when it comes to landfalls. We did experience a couple of tropical cyclone landfalls right around the northern Gulf Coast, and we do see that we did see a hurricane landfall, nearly a Category 2 hurricane, right in between the border of Louisiana and Texas, but we do see not much tropical storms form this hurricane season. However, it's good to point out that this year is under a negative Atlantic multidecadal oscillation, so the sea surface temperatures were naturally a lot cooler. So the 2023 hurricane season could be much different, not only because we're in a positive Atlantic multidecadal oscillation for the 2023 hurricane season, which brings a lot sea surface temperatures a lot warmer than usual, but we're also in a record-breaking year when it comes to the sea surface temperatures over the northern Atlantic, which is the reason why, despite the fact that the 1957 hurricane season is similar in a lot of ways to this hurricane season, I don't expect it to be necessarily a very good reference point, because the sea surface temperatures this year are much warmer than average. But a trend we saw with the 1957 hurricane season, based coming from 3 consecutive La Ninas, is that there's less storms than usual and more storms develop a little bit further westward, which makes sense because the upper level winds coming from the west are a lot stronger, which tends to steer storms a lot further eastward. And here's how the 1976 hurricane season looked like, and we do see that there were much more tropical storms, tropical cyclones that developed than usual, where we saw 21 tropical cyclones develop in the northern Atlantic, which is much more than usual. You could almost consider this hurricane season as hyperactive. However, the good news is that we didn't see much in terms of landfalls in the United States. We saw a couple landfalls in Florida which were considered tropical storm or tropical depression status, and we did see a borderline hurricane make landfall somewhere in Long Island, but we see that majority of the tropical storms that formed or hurricanes that formed were a lot further eastward than the United States, which is certainly a hopeful scenario that the El Nino wind shear would be able to deter a lot of storms from being able to head a lot further westward. But again, the 1976 hurricane season occurred when sea surface temperatures were naturally a lot cooler, since this was under a negative Atlantic multidecadal oscillation. I don't expect the 2021 hurricane season to exactly mimic this, but I do expect that it's certainly more possible we're going to see an above average hurricane season like the 1976 hurricane season is suggesting right now. But based on what we saw with the 1957 and 1976 hurricane seasons, when it comes to the exact trajectory as well as storm formations, we could naturally expect that storms will develop a lot further eastward than usual thanks to the strong El Nino hurricane season. But I do expect that the warmer than average sea surface temperatures of the 2023 hurricane season will make it much more hyperactive than these two hurricane seasons. Here's a look at the Atlantic Multidecadal Oscillation Index over the past, 100 years. And we do see that during the 1976 hurricane season, it was under a negative Atlantic Multidecadal Oscillation, which means that sea surface temperatures in the Atlantic were much cooler than average. And what we're seeing right now in 2023, where the sea surface temperatures are record-breaking when it comes to warmth. So despite the fact that the 1957 and 1976 hurricane seasons were very similar when it comes to the fact that they both occurred during an El Nino and after 3 consecutive La Niñas, the 2023 hurricane season is a much different animal when it comes to sea surface temperatures. But I could suspect that based on those two analog years that the storms will develop a little bit further eastward, so the East Coast could be impacted a little bit more than, let's say, the Gulf Coast. But since the sea surface temperatures are much warmer, expect more storms than what you saw during those two analog years. We clearly see the difference between a positive Atlantic multidecadal oscillation and a negative Atlantic multidecadal oscillation, where during a negative phase, the sea surface temperatures are much cooler than a positive phase. So since we're in a positive phase, we should naturally expect more storms than usual this hurricane season. So here's my forecast when it comes to the 2023 hurricane season compared to the short-term average between 1991 and 2020, which pretty much encompasses the years where we were in a positive Atlantic multidecadal oscillation. So it's easier to identify how relative to a positive multidecadal oscillation, how active this hurricane season will be than, let's say, a long-term average, where it would include years that we were in a negative Atlantic multidecadal oscillation, which wouldn't really give you a relative amount of storms or how active this hurricane season will be if you weren't necessarily alive during the negative Atlantic multidecadal oscillation years, which were well before 1995. And so here's my hurricane season forecast. So I'm expecting more storms than usual, 19 versus the average, which is 14 named storms. This is a rise compared to my previous hurricane season forecast, and I risen this forecast because I do expect that the record-breaking warmth when it comes to sea surface temperatures will play a major role in terms of potentially making this a hyperactive hurricane season. I'm expecting 11 hurricanes, which is up 2 more compared to my last forecast this hurricane season, which was 9 named storms, and 4 more compared to the new average. As again, the sea surface temperatures I think will play a big role. We already saw not one, but two tropical cyclones form in the main development region during the month of June, which is very, very rare to see. Which gives me a good indication that the main development region will be hyperactive when it comes to tropical cyclone formation. And then I'm expecting 5 major hurricanes as opposed to 3, comparing that to the new average. So here's my overall hurricane season forecast and where exactly I expect the most tropical cyclone formation. So in the main development region, I expect tropical cyclone formation to be hyperactive. You should expect multiple tropical storms and hurricanes moving through this area thanks to the record-breaking warm sea surface temperatures over the northern Atlantic. And I don't think the El Nino will play much of a role in terms of stopping the main development region from experiencing a hyperactive year when it comes to cyclone formation. Above average cyclone formation in the lighter red, you should still expect more tropical cyclone formation than usual in this area. This includes portions of the southeast coast as well as Florida. I did move this a little bit further westward because the much warmer than average sea surface temperatures are moving a little bit further westward as well. And I expect it to be mainly average in the western Gulf of Mexico and the Caribbean. We still need to keep in mind that despite the warmer sea surface temperatures, we're still in an El Nino pattern, which will bring more wind shear than usual, especially over this area. So I expect more so close to the average when it comes to tropical storm or hurricane development in this area. But the East Coast definitely needs to be more aware this hurricane season, because I do expect more tropical cyclones to take this sort of direction, moving up the East Coast rather than towards the Gulf of Mexico, since an El Nino does bring stronger westerly upper level winds that would force the storm a little bit further to move northward, a little bit further eastward. So definitely keep that in mind along the East Coast. But that's it for now, guys, and I thank you guys for watching.